right. How's everybody doing today? Welcome back to another day of class. We're going to go ahead and jump in and get started here. But before we do that, does anybody have any questions or anything that they would like me to go over before we just jump right into the the problems that we were looking at before? All right. So let me just see. All right. So just say hi if you're here. And I do want to say that I haven't graded the quizzes yet. Sorry about that. I've been swamped with all of this online stuff, trying to get it out. I did finish grading the labs, which I wanted to make sure that I did, because remember, you guys, well, back when I was in the hospital, that you guys all submitted those labs, and so I went through those. They were looking pretty good. Pretty much everybody figured out what the result was and all that, for the most part. I think there were a couple people that were struggling on that, but most of you guys got it, so good job on the lab, guys. And I've been going through the homeworks. A lot of technical issues, guys. Please work, with these technical issues. Even Google is having technical issues during this time because there's so many people going online now with the coronavirus and all that. That literally YouTube is now limiting the bandwidth for live streaming, and it's cutting back on high definition stuff and all that kind of stuff. So if even Google is having troubles, then you can imagine why we're having issues with Google Classroom, YouTube, and all that kind of stuff. So stick with it, and hopefully it's going to get smoother and smoother as we go. So anyway, let's just let me see any questions at all before we begin with the problems that we're looking at. Okay. So if there are no, let me see. Yo, Mr. Ketz, are there any multiple choice on the test, or is it just free response? Good question. Free response only. This test will only be free response. Even if we were having it in class, it would only be free response. And it makes sense because there's not a whole lot of concepts going on here. It's really going to be math problems. And so the format, I think I already posted a sample practice test for you guys. Okay. Now that isn't due anytime. Just like always, I'm not going to give you guys a grade for the review problems. And I'm going to post, I'm literally going to go through the answers today. So if you haven't seen the practice test, if you haven't gone through those, you probably just want to not even listen to the live stream, or listen to the first part of the live stream and then come back later and listen to the rest. Now, hopefully I'll be able to get through all the problems. If I don't, I'll have to record some tomorrow too. So we'll see. But I'm going to try to get through all the problems, but I do have a class coming up after you guys. So I'll go through however much I can go through. So the test will look a lot like that practice test that I gave you guys. That was literally from a previous year's test, but it will be obviously different reactions, different numbers. There will be slightly different types of problems too. It's not going to be exactly the same. So just because I set it up and ask a question a certain way on that test, don't expect it to be looking exactly the same on your test on Friday. Okay. So expect a little bit of variation there. Also, I'm not going to have any definitions. All right. That would be, pretty silly in terms of for you guys doing this online. There won't be any definitions for you guys to fill in. Okay. So it's going to look very similar, except it's not going to have definitions. It's going to have fill in the blank on the first page. Fairly straightforward, moles to moles stuff on the first page. On the back page, it's going to be all kind of like grams to gram stuff, or molarity stuff, or moles to gram stuff. It's going to be a mixed bag of different stuff on the back page. But the format's going to be very, very similar to the test that I showed you guys before, the practice test. Okay. The test is on Friday, not Thursday. Friday. Thursday is just going to be a work day. I don't typically hold any classes on Thursday. I don't even know what week it is. I guess it's a B week, which we wouldn't meet anyway. But I don't typically have classes on Thursday. But if you guys need the help, I can offer an extra live stream session on Thursday, let's say 2:30-ish, if that would be something you guys are interested in. Okay. Can you go over the difference between G to G and moles to G? let's go over these problems. You can go back and go over the videos, and if you still have questions on the difference, we can look at that. Okay. You don't know what to do for G to G. We have literally done like tons of G to G, grams to grams problems. Okay. And I've got 2 videos addressing this, right? Stoichiometry with mass and stoichiometry grams to grams tricks. You guys can check those out. I want you guys to look at that, and I want to go ahead and just jump into these problems because this is stuff we haven't gone over yet. All right, before I address those. But again, so Sam, please check out my videos, stoichiometry with mass and stoichiometry grams to grams tricks, and they're gonna literally address those questions you got. Okay. Do we print the test out and then send you pictures? Yes, that's the best way. If you don't have a printer, no problem. Just do it on Notability and upload that file. Notability uploads work great. Just whatever format. I don't really care. I want you as much as possible to try to upload the file. Okay. If worse comes to worse and Google Classroom shuts down, you can't upload it, just email it to me. That works too. Okay. But I don't want a whole bunch of emails. Okay, so please upload it to Google Classroom. And I don't care whether it's a PDF, a JPEG, a Notability file, whatever. Just upload it to Google Classroom. All right, so let's jump right into these problems. These are some homework problems that I assigned you guys a while ago, and they were due yesterday, but we had the quiz, so we didn't go over them yesterday. And then we're going to jump right in after that to the practice test. And look at that. So we can look more at what the actual test is going to look like. Okay. Print it out. Don't do it on Google Classroom. Yes. Don't do it on Google Classroom, but upload it to Google Classroom. Okay. So print it out, take a picture, or you can do it on Notability, but I wouldn't do it on Google Classroom. That's right. So don't do it on Google Classroom, but upload it to Google Classroom, either from Notability or from a picture or whatever else you have that works. All right, so let's jump right in. All right, so we got a problem. So a couple problems. We have magnesium metal reacts with aqueous cobalt 3 sulfate. Probably not going to happen because cobalt 3 sulfate is going to react right away with the water. But anyway, it's a nice hypothetical problem. So we have magnesium metal, Mg, and it's solid, is going to react with aqueous cobalt 3 sulfate. So cobalt 3 sulfate, we know that means this is a cobalt 3 plus, and this is sulfate is SO4 2 minus. So that 2 is going to go to the cobalt, so it's going to be CO2 SO4 3, and saying aqueous, and that's going to react to make, it says cobalt metal, COS, and aqueous magnesium sulfate. We know magnesium is always going to be a positive 2 charge when it's in an ionic form. And so it's going to be MgSO4, magnesium being +2, sulfate being -2. And it says aqueous for that. Okay, so that's our reaction. All right, hopefully you guys got that reaction. And it's not balanced. So let's go ahead and balance that. Where to start? There are a couple of places we could start. So we have 3 sulfates here. So I'm going to do the sulfate as a package. So I have 3 sulfates here. So I'm going to put a 3 right there in front of magnesium sulfate to balance the sulfates. It's going to give us 3 magnesium. So I put a 3 in front here. And then I'm going to have 2 cobalts here. So I'll put a 2 in front of that. And that should be balanced now. Okay? All right. So once I've got that reaction balanced, we can go ahead and try to solve it. So we have, let's read through it. So, what kind of reaction is that? We can just answer that first. What you guys got? That's single replacement. We know because we have a single metal, and it's doing an oxidation reduction reaction there. So this is going to be single replacement. If you answered redox, you'd also be correct. So I would accept either one. They're both correct. Okay. All right. So it asks us, so skipping down here, it says, what is the limiting reagent? So we know this is a limiting reagent problem. So we know that we're going to need to set up 2 separate types of equations here, 2 separate types of conversions so we can figure out what the two different possible theoretical yields are, and the smaller of those will be the theoretical yield, and the reactant that makes that smaller amount will be the limiting reagent, and the actual yield should be in the problem. So if we look back at the problem, and it says she collects, we know, okay, that is the actual yield. So we can go ahead and circle that. That's the actual yield. Okay. So let's set this problem up like this. I'm going to have 3.32 grams of magnesium. That's what I'm starting off with. And I have 175 milliliters. I'm going to just write this down here. 175. Well, we want to always make sure those are in liters, so that's going to be 0.175 liters of my cobalt 2 sulfate, or sorry, cobalt 3 sulfate. So this is going to be 3 steps for both of these, but let's just start with this one. So if we have grams to grams, and Sam, this goes back to your question about grams to grams. The first one, we're starting off with grams. We have 3.32 grams of magnesium, and we want to solve for how many grams of cobalt that you can make from that. So this is going to be a grams to grams problem right up here. Always going to be 3 steps when you go grams to grams. And the steps are going to be, first, we're going to convert that to moles. Then we're going to go moles of magnesium to moles of product. And then last of all, we're going to go moles of product back to grams of product. Okay? So grams to moles, and moles back to grams for this 3-step process. And so if we're starting with magnesium, the very, very first thing that we want to do is that we want to convert this grams of magnesium to moles of magnesium. So we're going to need the molar mass. So we're going to put 1 mole on the top because we want to go from grams to moles, and then the 24.305 grams on the bottom. And by the way, I'm getting that from where? I'm getting that from the periodic table. Notice, right, that's just magnesium right there. Yes, there is a 3 in front of magnesium, but no, this 3, the coefficient, does not get included in the molar mass. The molar mass has to do with the chemical, has nothing to do with the balance equation, so it's going to be 24.305 there. Okay? So now we've gone from grams to moles, so we need to go from magnesium to cobalt, because cobalt is the product. And why am I going to solve for cobalt? So let me just write up how we're going to solve for cobalt. So we have magnesium on the bottom, cobalt on the top, and this is 3 and 2. Why am I solving for cobalt? Anyone? Is the test open notes? Yes, the test is open notes, but that's not the answer to my question. Why are we solving for cobalt? Anyone? Why are we solving for cobalt here? Why do I put 2 cobalts on the top? Okay, I'm not seeing any answers, so I'll go ahead and just answer it then. We're solving for cobalt because that's what she collected. That's what the actual yield is in. Yes, very good. That's what the actual yield is in. So we're going to solve for cobalt in that case, and that's why we put 2 cobalts on the top. Okay, what we're solving for goes on the top. What we're starting with goes on the bottom, and this is 2 because of the balanced reaction, and this is 3 because of the balanced reaction there. Okay. Last of all, we need to convert this moles of cobalt to grams of cobalt. So we're going to put 1 mole on the bottom, right? Because we're in moles already. We want to cancel out the moles and go to grams. And we're going to use the molar mass of cobalt, and that is 58.933 grams. And again, getting that number directly from the periodic table, which is, move this over, which is right here. So we have a question. There were some problems with Google Classroom, so I emailed the homework. I hope you got it. I hope I got it too. I think I did. I don't, off the top of my head, I don't remember exactly what I got from who. But yes, I know you guys had problems with Google Classroom. Okay. So, all right. So we got this all set up very, very nicely here. Let's do the math. Plug it in the calculator. So I'm going to break out the calculator. And here we go. Again, always multiplying by numbers on the top, divided by numbers on the bottom. We can ignore ones. So it's going to be 3.32 divided by 24.305 times 2 divided by 3 times 58.933. No parentheses necessary whatsoever if you type it in the way I did. Okay? So we have our answer of 5.3, and let's round it off to 3 sig figs, 5.37 grams of cobalt. Okay? 5.37 grams of cobalt is how much you could make from that much magnesium. Okay? But we're not done yet because that is assuming that magnesium is the limiting reagent. But maybe it's not. All right? So hold up. Do you count a subscript when calculating the molar mass like an H2? Yes, of course. Yes, yes, yes. Molar masses always do include these subscripts. Okay? Which we'll find in another problem, I'm sure, before we're done. Okay. So next part. We have 0.175 liters of cobalt 3 sulfate. And the first thing we need to do is convert that to moles. So we have liters, so volume to moles. The conversion factor for that is going to be the molarity, not the molar mass. The molarity is right up here in the problem. So that's going to be 0.275 moles per liter. Okay? And once we're in moles, then we can go ahead and do these conversions like normal. So we have back to the balanced reaction. If we're starting with this cobalt 3 sulfate, we're going to have 1 cobalt to SO4 3 on the bottom here because there's no number. That's going to be a 1. And on the top is going to be, once again, the same product, right? 2 cobalt. 2 reasons. First of all, that's what the actual yield is in. But secondly, and more importantly, these two must be the same. You must solve for the same product whenever you're figuring out the theoretical yield and the limiting reagent. Okay? If they're different, then you've messed up already. So these two on the top must be the same. And so, of course, the last step is going to be the same, 58.933 grams in 1 mole. So last of all, converting that to grams. Okay? So this is a grams to grams problem, and this down here is how it's going to look for a molarity type stoichiometry problem. Okay? And so this is a beautiful problem, right? It's got both things all in one. Let's do it. There are only 3 people. Only 3 people. That's okay. No, actually, I'm seeing that there are 12 people. But anyway, let's go ahead and do this. So we're going to start off 0.175 times, multiplied by numbers on the top, 0.275 times 2 times 58 point, I don't know if you guys can see that, 58.933. Okay? And wow, that's really, really similar, right? We got that pretty similar. So that's going to be 5.67 grams of cobalt there. Okay? So we have 2 results that look really, really similar, and we have to figure out, okay, which one is going to be the limiting reagent, which one is going to be the theoretical yield. So we look at these, we say the smaller one. The smaller one is the theoretical yield. Okay? Because once you make 5.37 grams of cobalt, you can't make any more because why? You've run out of magnesium, which means the reactant that makes the smaller amount, that is magnesium, is the limiting reagent. So Mg is limiting reagent. Okay? But we're not done quite yet because we still have one last thing, and that's the percent yield. The percent yield is going to be a measure of how good a job this reaction worked or how well it worked. And so what we're going to do is you're going to take the actual divided by the theoretical times 100 just to turn it into a percent. And so that's going to look like what? That's going to be 1.99 grams divided by 5.37 grams times 100. And let's see what that looks like. 1.99 divided by 5.37. And that's going to be 0.37, which is the same as 37%. And if we have three significant figures, which I do believe we have, that's going to be 37.1%. Okay, questions, guys? 37.1%. All right. So that is a great question. You guys might see something like that on the test, but again, the wording is going to be different. It's going to be similar in terms of how this is going to work, but the wording is going to be different. So that's a single replacement type reaction. And then the next question is going to be a double replacement type reaction, right? And so we will, unless there are any questions on this, we're going to jump into the next one, which is the double replacement reaction. Okay? So let's go there. Okay? So write the balanced double replacement reaction. Let me get this off here too. Between what? We have sodium hydroxide and nickel 2 nitrate. This is definitely a reaction that would happen in real life. So we have sodium hydroxide, NaOH, aqueous, nickel 2 nitrate, NiNO3, 2, right? Because nitrate's -1, nickel is +2. And it doesn't even tell you what the products are going to be. So we got to figure it out, right? So sodium is going to go with nitrate. So first thing with the last thing. So NaNO3. And we know that all nitrates are soluble, so that's going to be AQ. Plus the nickel is going to go with the hydroxide. Nickel is +2, hydroxide is -1. So is NiOH2. And hydroxides are mostly insoluble with a few exceptions. And this is not an exception, so that's going to be solid, which means our precipitate is nickel 2 hydroxide. So precipitate is what? Precipitate is the nickel 2 hydroxide. All right. So that's our reaction. Is it balanced? Let's see. No, right? So we have 1 hydroxide, 2 hydroxide. So we need to make 2 hydroxides on that side. That's going to make 2 sodiums. So we need to put a 2 here to make 2 sodiums. That's going to make 2 nitrates, which we already have 2 nitrates there, all balanced. So that looks good now. That's the reaction. All right. Oh, hey, what is that? Is that Spanish? I don't even know. Man, that's really sad. I'm sorry. I can't read that question. Titrations. This isn't exactly titration, but it is a double replacement reaction. So let's jump into this. So we have Jackie this time is mixing these two together, and they're both going to be molarity type problems, and so we're going to solve them both in that way as molarity type problems. So let's start off with the amounts of both. We have 15 milliliters, and we of course need to convert that to liters. So I'm going to make 0.015 liters of what? Of sodium hydroxide. Remembering to always put the units and the chemical right there so that we don't get confused. And she's mixing that with what? 25 milliliters. That's going to be 0.025 liters of your nickel 2 nitrate. So NiNO3, 2. All right. And these are going to be 3-step problems. Anytime you have this molarity stuff, it's typically going to be 3-step problems too. But let's look. After the reaction, she collects 0.118 grams of nickel 2 hydroxide. That is our precipitate, and that is our actual yield. So just keep that in mind, that 0.118 is our actual yield. Actual yield always being something you don't calculate. It's in the problem itself. So back up here. How do we do this? If we want to go from liters to moles, because of course the first thing that you want to do is convert it to moles. If you want to go from liters to moles, oh wow, it's actually octane. Is that even how you say it? The Catalan language? Wow, that's pretty cool. Didn't Didn't know that. All right. So back over here. So if we want to go from liters to moles, and we always want to convert first to moles, we're going to use molarity in order to do that. So molarity to do that, we have this 0.25 moles per liter here. So that's going to be 0.25 moles per liter here on top, and liters on the bottom. Next step is we're going to go from moles of one thing to moles of another. And then finally, we're going to convert that over to grams. So we have, starting with sodium hydroxide, so we're going to put sodium hydroxide on the bottom. We get 2 sodium hydroxide. And we want to solve for the actual yield. Then that's going to be the nickel 2 hydroxide. Okay? So we look over here at nickel 2 hydroxide. And so there's only one of them. So it's going to be 1 NiOH2. Again, choosing that because that's what we're collecting. That's what the actual yield is in. Make sure that you're always solving for what the actual yield is in. Okay? Nickel 2 hydroxide on top. And last of all, we want to convert that into a mass. So 1 mole on the bottom, and on the top, we need the molar mass of nickel 2 hydroxide. So we need to pause and calculate that value. All right? So I'm going to go ahead and do that. Let's do that on the bottom here. We have NiOH2. That's going to be the mass of nickel, which is 58.693 plus 2 oxygens, 15.999 plus 2 hydrogens, 1.0079. Add it all up, and let's see what we get for the molar mass of nickel 2 hydroxide. 58.693 plus 2 is 15.999 plus 2 times 1.0079. And that's going to get that's our molar mass of nickel 2 hydroxide. That's 92 point, I don't know if you guys can even see that at the bottom there, 92.7068 grams per mole. Well, we'll just round that up. And so let's write that over here back in our problem, this 92.707 grams. Okay, you guys with me? Let's do the calculation. And this is nice. We're going to keep that molar mass down here, so we don't need to do another molar mass calculation. Okay. So for a lot of questions I didn't even notice. Is the homework just working on the review? Yes. In fact, I'm not even going to collect it. So just prepare for the test. You don't have to worry about any more homework, but I would highly, highly recommend that you do the review, especially because it was a previous year's test. You're going to get a real good idea of what the test is going to look like. So go through that test. I'm not going to collect it. And yeah, prepare for the test on Friday. When does the test due? The test, you will have literally 45 minutes to do the test, and that's it. The same format as a quiz, but hopefully you guys got the idea, and you're not going to be spending a half an hour trying to print something out or something like that, and you don't waste your time. So you got 45 minutes to do the test, which, it might be tricky, but I think you can do it, okay? Don't have my scientific calculator on hand. All right. So sodium. All right, anyway, so let's come back over here and do the calculation back here at the problem. All right, we have 0.25. Sorry, I missed the first one. We have 0.015 times 0.25 on top, divided by 2 because the 2 is in the bottom, and then times that molar mass. I'm just going to use the number that's in my calculator, so I use second answer, and hit enter. And this is going to get me a mass of, pretty small mass, of 0.1738. So let's round it up to 0.174 grams of our nickel 2 hydroxide. Okay? So, how many questions the test? Similar to the practice test. All right, similar size. Okay, So now we're not sure, we're not done yet. We're not sure what the limiting reagent is. So maybe it's sodium hydroxide, maybe it's nickel 2 nitrate. So we need to solve for nickel 2 nitrate. Same kind of deal with that. It's going to similarly be 3 steps, and the last step is going to be the same. Always that last step being the same when you're doing this limiting reagent type problems, because you're solving for the same product. Okay? So if this is nickel 2 nitrate, we have 0.025 or 25 milliliters of, and our molarity back up in the problem is 0.1 mole per liter. Okay? And we want to take those, the nickel 2 nitrate. So if we're starting with nickel 2 nitrate, so it's going to be 1 NiNO3, 2 in the bottom. And we're solving for nickel 2 hydroxide, so there's only one of those also, NiOH2. So 1 over 1 for nickel. And then last of all, the last step is always going to be the same. We have 1 mole in the bottom, 92.707 grams on the top. And that's it. That's what it's going to look like. Okay? So we can go ahead and solve that. 0.025 times 0.1. And we don't even need to do anything here, right? Times 1 over 1. We don't need to do anything. And then multiply by the molar mass of 92.707. Hit enter. And that's going to be 0.2317, rounded up to 0.232 grams of NiOH2. Okay? So once you're there, the limiting reagent becomes apparent. Your limiting reagent is the reactant that makes the least amount of product, and that's going to be this, right? Your nickel 2, I'm sorry, no. Sorry, back up here. The limiting reagent is going to be the reactant that makes the least amount of product, and that's the least amount of product is this. So your sodium hydroxide is the reactant that makes the least amount of product. And let's get a different color here. That is our limiting reagent. Okay? And you can just say sodium hydroxide is the limiting reagent, or you can say 0.015 liters of sodium hydroxide is the limiting reagent, but you're going to just have to say sodium hydroxide. That's the limiting reagent. Okay? Next, the theoretical yield is going to be this. It's going to be the smaller of the two. It's always the smaller of the two, because once you make 0.174 grams of nickel 2 hydroxide, you will run out of sodium hydroxide. So this is the theoretical yield. Okay? And I haven't mentioned it, didn't ask about it, but I want to make sure I do this because it is on the test, that the other reactant, there's an excess of. Okay? You don't necessarily need the amount, how much excess, just that there is an excess or an excess of NiNO3 too. Okay? So that's your excess. Last of all, it says calculate the percent yield. So the percent yield is going to be the actual yield, which we said is 0.118 grams. Where do I get that? Back up in the problem. It says she collects 0.118 grams. That's your actual yield, divided by theoretical yield of 0.174 grams. Multiply that by 100 at the end. And so let's calculate that together. 0.118 divided by 0.174 and multiply by 100. That's going to be 67.8%. Okay, 67.8%. Okay. You guys can look at that here, and I'm going to move this back over into the full screen and answer some of your questions. Is the practice test going to be due tomorrow, or is that just suggested? That's just suggested. Okay? The practice test, I will not collect it. Okay? You do it or you don't do it, I don't care. But if you don't do it, you're not going to have as good a chance to do well in the test. Okay, so do the practice test, and that will prepare you for the actual test. What tests do, O'Brien? The test, we're talking about, you have a test on Friday. The test on Friday You will get it on Friday, and you will return it on Friday, 45 minutes later, or less than 45 minutes later. You have 45 minutes to do the test, and that's it. It's one piece of paper, just like the practice test, except that it does not have any definitions. You don't have to define anything. So, without further ado, we do not have time for the entire practice test, but I think I do have time for the front side of the practice test, and I'm gonna live stream tomorrow, okay? And I know it's Thursday. We don't normally meet Thursday, so I'm gonna live stream tomorrow at 2:30, okay? After all your classes should be done, and I'll go over the other half of the practice test or whatever we don't complete, and I'll be here to answer your questions. So 2:30 tomorrow. Once again, I'll give you guys the link on Google Classroom. Okay, so for the last remaining time, let's check out the practice test, just the front side. Now, the front side should be easier for you guys. Okay, it should be easier for you guys, but sometimes people tend to complicate things and make things harder than they actually should be. So, yeah, keep that in mind. All right, we can define all these things. I really want to get down to the problems here because, again, you won't have definitions on the test itself. Okay, molar mass, that's the mass. So we'll just do this quickly. Mass of 1 mole of something, right? And that's going to be our conversion factor. Molar mass is our conversion factor between grams and moles. Theoretical yield, that's the amount you should get if everything works out perfectly. The actual yield is the amount that you actually get, okay? The limiting reagent, which we've talked about, that's the reactant that limits the amount of stuff that you can get, all right? And the excess is the reactant that there is left over of, all right? Reactant with extra, all right? Reactant that limits amount of product. Okay. So let's jump down to the bottom part before we close up here, because this is a beautiful set of 9 questions which are easy but really get to the heart of stoichiometry, right? This is all moles to mole stuff. So it's all one-step stuff. You don't need to have any molar masses. You don't need to worry about molarities. It's just a simple, straightforward stoichiometry at its rawest state, okay? Why is that? Because everything's in moles and we have nice whole numbers. So let's do it together, okay? You will get something like this on the test. And please do expect the test to have something like this where you're just doing this moles to mole stuff, okay? So first of all, you got to balance the reaction. If you don't balance the reaction, you're going to have problems, okay? And if you haven't gone over this yet, if you haven't done the practice test yet, just get out of this the live stream and just do it on your own first. Don't watch me solve this. Try to solve it first, okay? And then you can always come back and watch the YouTube video anytime you want, all right? So just leave the live stream now if you haven't done it yet. All right, so if you have done it, let's check this out. You can always come back later. So we have nitrogen. We got 2 nitrogens here, so we're going to put a 2 there in front of the NH3. And that means we have 6 hydrogens, so we're going to put a 3 there in front of the H2. Okay, hopefully you guys can see this. I know it's a little bit small, but I wanted to use the actual test. Now we got to fill in the blanks. The maximum amount of NH3 that can be made from 5 moles of N2 is what? So if we have 5 moles of N2, now you can literally do this in your head, but if you want to set it up, we're going to set it up like this. We have 5 moles of N2, and our conversion factor will be the balanced reaction. Okay, so we're going to have 1 N2 on the bottom, and we're solving for what? NH3 is 2 NH3 on the top. Okay, that's our conversion. 1 step, moles to moles, 1 step conversion. So 5 times 2 is 10. Okay, same thing down here, although we have a different reactant that we're looking at. So the max amount of NH3 that can be made from 12 moles of H2, so So we write 12 moles of H2, and we are starting with H2, so we go back to the balance reaction. So we have 3 H2 on the bottom. We're solving for NH3, 2 NH3 on the top. You guys should be able to do this in your heads. You're welcome to use your calculator if you want. I really don't care how much you use your calculator, but let's see how this works, right? It's 12 times 2 is 24, divided by 3 is 8. So this answer is 8. Okay. And that's, the most calculations that we're doing so far on the front page. Next, the limiting reagent of Bob's reaction is what? The limiting reagent is not a number, it's a reactant. It's the reactant that makes what? The smallest amount of product. So we say, okay, the smallest amount of product is 8. The reactant that made that was hydrogen, H2. The theoretical yield is, it's going to be one of these. It's not a new calculation. It's going to be one of these. It is 8, the smaller of those two numbers. That's the theoretical yield, okay? The actual yield is what? The actual yield is written in the problem. It's always written in the problem. So we're going to go back up to the problem, and we read, only collected, key word there, or got, or weighed, or something like that. 6 moles, okay? Nice whole numbers. The percent yield. Now, you can do percent yield with grams, or you can do it with moles. Either one works. It's always going to be actual divided by theoretical. It's going to be 6 divided by 8, okay? Which is the same as 3 over 4, which we know, of course, 3/4 is 75%. No calculation, or no calculator needed for that one. There's an excess of what? We have an excess of the other thing. So if our limiting reagent was H2, we have an excess of N2, the other reactant. Okay? And then last of all, looks like we have to do another calculation here. If Bob wanted to have no reactant in excess, he would need to combine blank moles of H2 with 5 moles of N2. So if we have 5 moles of N2, and we want to know how many moles of H2, we're going to set it up like this. 5 moles of N2, and we want to figure out, all right, how much H2 would you need? So there is 1 N2 for every 3 H2 based on the bounce reaction. So let me see if I can fit everything in here. So 3 H2, okay? So this is going to be 5 times 3 over 1 is 15. So that's going to be 15 moles of H2. And that's the front side of the paper, okay? All right, you're welcome. Hopefully this makes sense. Oh, is this chapter 3? We, actually, this is all just stuff I made up. So I don't know what book you're using. I'm not using a book for this one. I will be using a book for the next chapter when I go through acids and bases, but this is all just stuff I made up. So not really in any book. All right, so that's it. Class is over. Any last minute questions before we just sign out here? Last minute questions. Okay, if there are no last minute questions, we're just going to go ahead and sign out. Have a great rest of your day. And once again, I'm going to go ahead and live stream again 2:30 tomorrow just to help you guys out because I know you guys have a test on Friday. All right, see ya.